Today we'll get started with exploring what is data modeling is all about, what is called relationship, and how to define or create relationship between tables. And previously, you have learned how to connect to different data sets using Power BI, and also you have seen how we can perform data reshaping, data cleaning, data pre-processing as part of Power Query Editor. And now we will see what exactly data model and why we need to do the data model design. And then let's see how to create relationship between tables as part of this session. As part of this, yes, we'll start with understanding the what and why of data model, why we need to do the data model design. Is this specific to Power BI? No, data model is not specific to Power BI. You take any application before you build the application, you need to have a solid data model design should be in place. Okay, so the data model is kind of the building architect's blueprint. Without blueprint, if you construct a house, how it is going to be later point in time. If you want to make changes to your house design, in the sense after construction, what is going to happen? It is going to be a major rework. It involves more money, right? You need to spend, the cost is more. And again, a lot of confusion, especially if you buy an house in a flat apartment. And if you want to break something, you need to get approval from everyone. Okay. So a lot of issues are there. Hence, make sure that before you develop any application or before you start creating a report or dashboard in Power BI, you need to create the data model design. Yes, you are correct, Deepa. So Lena, yeah, sorry. So in the case of Tableau and ClickSense, you don't have to create the data model. Okay, the data model, you need not to create it there. It takes care of it automatically. But when it comes to Power BI, you need to the data model design. Okay, now the question is, in our case, we have an SQL Server database already there. That is our source database. That is where they created a data warehouse database. They have done all the data model design, everything. In that case, you don't have to do the data model design from the scratch, but still make sure that the relationships are correctly defined in your report file also. Okay, if you don't define the relationship, or if the relationships are not detected automatically, it is your responsibility that you need to go and create the relationship explicitly. Otherwise, your report will not show the data accurately. The data model is a universal concept, okay, and it is not related to Power BI. But what Microsoft recommends is, as part of Power BI, yes, you have to do the data model design. As part of data modeling, you need to make sure that you have created or established the correct relationship between the tables. Otherwise, it will not do the filtering. Okay, as part of data model, why data model? Using data model, we define the relationship between in the tables. So let's say if you have more than one table, you need to create the relationship between the tables. For example, you need to indicate the relationship between the customer and their orders, right? So you need to have some kind of relationship, and also customers orders what products. Okay, you need to create a relationship between customer and orders and products, and again, products and categories. You need to create a relationship between these because each tables interact with one another. So with this talk, with this type of relationship in place, you'll be able to, you'll be able to do the filtering correctly. Your report will show the correct information. Otherwise, it will not do the filtering at all. Okay, there are three types of, as part of data model, there are three types are there. Instead of saying types, we can say three phases. One is the conceptual data model phase, other one is logical data model phase, and physical data model phase. And what is conceptual data model? What is physical data model? What is logical data model? The conceptual model, as part of this, we'll be focusing on capturing the abstract of the business concepts and the relationships, okay, without considering the technical implementation details. It's something like later, as part of your project, you travel to the customer side as a data model architect or data architect. You conduct a workshop with the line of business manager. For example, you have something like in USA, there is a sales team from the customer side, sales department. They call it as a line of business. Okay, sales, you Americans, they say department as a line of business. In the sales line of business, you conduct a workshop with all the stakeholders that are available as part of the sales department to understand their reporting requirements at a high level. Okay, to understand the reporting requirement at a high level. Okay, you are basically capturing the the entities. What are the tables that are required to build the model? For example, you have the sales table, and then how you need to filter the sales table. For example, you want to see the sales breakdown by location or by customer, by product, by stores. Okay, and you need to have date dimension when it comes to any data warehouse related data model. Okay, and you need to have the date dimension table. You need to have the stores dimension, the product dimension table, and customer dimension table. And then you have something else called subcategory. So there are some cases they use brand also. Brand, you want to see, which brand wise sales breakdown, which brand we are selling more, and which brand are we getting more margins. Like assume multiple tables are required. First, you need to understand what are the tables or the entities that are required in order to meet the entire sales team's reporting requirement. And also you will understand as part of the conceptual data model itself, right? How the tables are related with each other. For example, each customer, they raise more than one order, or each customer, we generated multiple invoices. And across the stores, the same customer may purchase it. A single customer may purchase it from more than one store also. Let's say in your location, let's say you live in a specific street or specific area in your city. In that area itself, you have 2 to 3 stores are there, okay, for this specific company. So you may use, may go to the store, or, we go to some other store, or let's say, your office location. Let's say you visited you went to office, and nearby to your office, there is another store is there. Since you don't have time to buy the groceries from the grocery that is very nearby to your house. What is nearby to your office? If any groceries, you go and buy it there. A single customer can buy product from more than one store also. So now you understood, the one-to-many relationship. Or a single customer may order more than one product. A single customer may buy from more than one stores also. Each location, you have multiple instances are there, right? Each location, multiple orders we received it across different stores. Okay, so first you understand, as per the conceptual data model, during the workshop with the sales team, comprehensively you understand what are the entities that are required and how these entities are related. What kind of relationship exists between these tables. At a high level you will understand. And then in the case of logical data model, what you do is you will find out the columns, attributes, each table, customer table, what are the columns that are needed. Okay, and you will see, you go one step further. In the case of logical data model, this is an extension to your conceptual data model. Once you are defined the big picture, and the next step is in each table, in customer table, what are the columns are there? The customer first name, and last name, and what's his name? Maybe your location, right? Very address details, and contact number, all the details. What are the columns that are required in each table? That you are going to define it as part of your logical data model. And this is called, the columns are also called as attributes. Attributes are nothing but columns. And also you define the relationship between the tables. Okay, here This is one side, this is many side, one-to-many relationship. Okay, you have something like a one-to-many relationship, and similarly your product. So here you will identify the attributes for each table, and you define the relationship. Are there any one-to-many relationship or many-to-one relation or many-to-many relation? You are going to define it here. Okay, and then constraints. You are going to define the constraints of the database system. Also, okay, that is what you do it as part of logical data model. Next one is the physical data model. In the case of physical, once you are done with the logical data model design, you share it with your customer for their review. And once they review, and if they are okay with this, they will do sign off. You get a sign off from the email, right? You go ahead with the next stage, the physical data model. The physical data model, what you do is for each column, for example, in the case of customer table, you just define the first name, the column name or the attribute, and what data type is this, varchar 2 of 60. You are going to define the data type and the width of the column. Also, you are going to specify it here. Okay, in the case of physical data model. Okay, here also you have the customer table, first name, last name, and address, email ID, contact number, and so on, right? So the last name is a varchar, address is an email, and phone number, need not to be a varchar. It can be a numeric number also, right? And so likewise, as part of physical data model, you are going to define the data type in addition to the attributes, and also you're going to define the width of each column and so on. Okay, that is what your physical model. Once you are done the physical data model design, again you share it with customers, and if they give any feedback, something like, hey, the first name Y60, make it to 40. Okay, reduce the size, and then again you redesign your model or make changes to the model suggested by the stakeholders of the sales department, and then again you send the document back to them for their review. And once they review it and they say, hey, everything is good, you go ahead with physicalizing this table into database. And then what they do, that is when the database administrator, they come into picture, they will create these tables in the database, the data warehouse database also. Now you understood what is conceptual data model, what is logical data model, and physical data model. Conceptual data model, yes, Lena, we do it as part of requirements gathering itself. Okay, so for if any new project comes in, when someone from India, our office, right, they travel it to the customer place. So that guy will work from the customer premises, and he's the one talking to the customers, all the stakeholders. And then you will capturing the requirements, everything. As per the requirements base, they will be capturing all the essential entities and relationships that exist between the tables. At a high level, they will capture it. And then it's kind of a blueprint. They come up with some kind of blueprint. And then the logical data model, what they do is they identify the columns for each and every tables. And then they create the relationship between the tables. And finally, they will specify or define the data type for each column as per the physical data model. They'll create everything. So this is how the data model design will evolve. Look here. So initially you have something like this. So sales table and product table and store table, how these tables entities are interacting with each other, time. Okay. And the next one is the logical model, and each and every table, what are the columns that are required. And finally, you define the data type, everything as part of physical data model. Okay. So this is what your physical data model. This is how it looks like this. Now the question is, yes, why data model? Why should I do data model design? Is it mandatory? Yes, it is mandatory. You have to do it. Okay, and look at this visual. This is a column chart. In the column chart, in the x-axis, we plotted the English month name. The y-axis plotted the sales amount. Each month, how much sales we made. But if you see here, all the month, the sales amount remains same. That means there is no slicing and dicing is happening. The English month name, this table or in this table's column, it is not filtering the sales amount column in the sales table. So this one maybe comes from the customer table. This one is from your sales or the fact table. So this table needs to filter this table. Since there is no relationship created between the tables, it shows all the values are same. This is wrong actually. It cannot be right. All the month you cannot say my revenue is same. What I will do is to demonstrate this, I will just to substantiate this, I just go to the Power BI desktop. This Power BI desktop. A lot of things got open. Let me close it. Power BI desktop. Okay, I just open it. I just launch it. Let us wait for a few seconds. With that demo, you'll be able to understand the importance of creating the relationship between the tables, or designing the data model. Okay. Let us give 1 or 2 seconds to launch it. Okay. 1 or 2 minutes, not seconds. It takes its own time. Yes, it has been done. 1 second. It is still launching it. This is a overkill. This is not at all required. The welcome screen and all. They can give some option here. You want the welcome screen to be displayed or not. Open a report here. Just open an existing report so that we don't have to do data cleaning everything. And here open a report. What is this here at the end? Yeah, browse report. Sorry. So this is my report file. Look here, and here I have the model view here. I have already loaded the tables here. And look here, we have, oh my God. So I'm very unfortunate. I did not open the correct file. This is our system. Okay, let me do one thing. I'll just close it. I saved it in the same name data model. That's what I was wondering. Okay, let me, give me a second here. I'll just find out here. File Explorer. Yeah, this is the one, part1.pbx, correct.
Okay, now let's get started. We'll start with the fundamentals.
Okay, I just go here and then the NC sales. Let me check NC sales. Yes, everything is there. And okay, I just go to the model view. In the model view, we have already created the relationship. Here, look here, the NC sales and the product dimension and category dimensions are there. And I want to see how many number of products we sold. Okay, how many number of products we sold, or how much sales we made by product. Okay, I just click on the plus sign here. I'm going to click on the column chart. Here the NC sales, your kind of your fact table. I just drop the sales amount column here. It gives me the total sales. Sales amount 4,56,000 or 456K. We made sales. And okay, 456K, fine. But is there any possibility that you can give me the breakdown of the sales by product? Yes, product name. I'm going to drop it here. You can see that how much sales we made in each product in total. What is the total sales we made in each product? That is what we can see it here. With this, we can make out quickly the, except ice cream, cashew nut, and shampoo. The rest of them we did not sell, including soap, right? The rest of them we did not sell much. Fine. Here, in the x-axis, the product name, and the y-axis, the sales amount is there. Okay. So these two columns are coming from two different tables. This one comes from my product dimension table. The sales amount came from my NC sales table. So in this case, these two tables should have relationship. If there is no relationship, this filtering is not going to happen. So for example, if I go here, and then if I select this relationship, the link, and when I right click on it and delete it, if I delete it, and when I go back to my report view, you can see that in all the products, the sales amount remains same. It is not doing the filtering correctly. Hence, data model design is very much important in the sense creating the relationship. The relationship should exist between the tables, otherwise it will not do the filtering correctly. Yes, the next thing is I'm going to click on expand. There you are the product ID. How do you create a relationship between the tables? For that, you need to have the common column between the two tables. there should be a common column, right? Between the two tables should exist. And here also I have product ID. Here also I have the product. I'm going to select the product ID. I'm going to drag this and drop it on top of this product ID column. And if you wait for some time, there is a magic. Look here, one-to-many relationship. A link got created here. I just dragged and dropped this product ID from here to here. And on, so make sure that you're dragging it, dropping it on the product ID column. Okay. Here also product ID, here also product ID. Okay. And when I dropped, automatically a link got created. But here you can see that on the product table side, we can see one. On the NC sales side, we can see star. That means, one-to-many relationship exists. A single product can appear more than one time in the sales table. That is what we can see that. So now we have created the relationship between the tables, and then we will go back and see, yes, only when the relationship exists between the tables, it is doing the filtering correctly. Otherwise, it is not doing it. It is not at all doing it. Okay. Fine. With this, you are able to understand the importance of relationship, creating the relationship between the tables. Okay. The product table filtered the sales table. Okay. So what do you mean by filtering, first of all? The next question is filtering. So what do you mean by filtering? So look at this one. We have two tables here, and you have the country table and you have the sales table. This is your sales table and this is your country table. Okay. And your manager, he wants to see the sales breakdown by country. For example, you want the United States, the country name should be displayed along with the sales amount. In US, how much total sales we made? In Australia, how much sales we made it? He wants to know that. And if you see here, 24,000 plus 2,700, 26,700. In Australia, 26,700 we made sales. Here, the United States, Australia, these two values are coming from the country table, this column, and this column data comes from this table. So if you have to query the data from more than one table, you need to create the relationship between the tables. Step one. Step two, you need to create the relationship between the two tables based on the common column. What is the common column exists between these two tables? Country ID and country ID. So you need to create a link between, you need to drag this one and drop it on top of the country ID column. Okay, I'm done with creating the relationship. Yes, then you can select the values from more than one table simultaneously. Okay, what is happening behind this? And when I create the relationship, so behind the scene, filtering is happening. What do you mean by filtering? So here it is a one side, this is a many side. What happens is, in these tables, the first record, the country ID, right? You create the relationship between these two tables based on the common column country ID. The country ID will be propagated to this table. Propagated is kind of a fancy term. It is nothing but the country ID US will be passed to this table. So once the value comes here, it goes and filters the data relevant to US. Wherever US is there, it is going to group them into a single group. So now in US, you have 4 records. All the 4 records will get grouped, and then it apply the sum on the sales and sum on the quantity. If you want total quantity, so you can use that one also. But if you wanted to see the sum of sales in Australia, right? So in US, what will happen? It will group all the records related to USA, and then it applies sum on the sales column. It will do that. And then it gives you the total sales units. And then it goes to the second record. The second record country ID will be propagated to this table. And then what happens, based on the country ID which it passed here, it is going to filter those records relevant to Australia AU. Now you have one more EU, right? Yeah, 3 records are there. So in that case, it apply the sum on the 3 records of your Australia data. Okay, sorry, this is not 26,700, and we have one more record, right? So, and it will add all the way, and then it goes to the Germany. The G will be copied here, and once the G get copied, it is going to filter all the G related records. So now G records got selected. That's why I have used the same color, okay? And 2060 and this value. So this is what is called as filtering. If you once you create the relationship between the tables based on the common column, it does the filtering automatically. We don't have to do it explicitly. That is the reason why. What happened here? So in this case, when I drop the sales first, sales amount, what happened? For example, I just remove this. I just drop the sales amount. It gives me the total sales, 456K, that's all, right? It is not giving me the breakdown of my product name. Okay, I need to drag and drop the product name into this table. So now the moment when I drop the product name here, it does the filtering automatically. It does the filtering automatically. How the filtering, how the breakdown, how it got, how it is giving the breakdown automatically. So initially we were seeing only one value, 456K. Now I want to see the breakdown of sales by total sales by product name. The moment I drop the product name, it is doing the filtering. In that case, what happened? Take this example, right? Let's assume that you have product ID or product ID. The first product ID will be sent here, and then it groups all the product ID, the similar product ID, in a single group, and then it applies the sales on it. Hence, to filter the data, right? For example, if you want your product table, if your product table to filter your sales table, the relationship is mandatory. You need to make sure that you are creating the relationship between the tables. Okay, now you understood what is filtering. Next one is the data modeling process flow. Like I said earlier, first you need to identify all the entities. Entities are nothing but tables for your reporting requirement. And also identify the properties of each entity, and then identify the relationship amongst the entities, and map the columns to entities or tables completely, and then visualize the data. If you are able to see the data are filtering correctly, then you are good, right? Then you assign keys as needed and determine degree of nomination, finalize and weight it with your stakeholders. This is a typical workflow when it comes to data modeling design. Once you are done with the data model design, you are all set. Okay, look here, as part of data model design, there are two types of modeling techniques. Other one is star schema, other one is snowflake schema. This is specific to your data warehouse. If you are working in a data warehouse, so as an analytics professional, or you take any analytics project, okay, especially the big customers, they already have a data warehouse. The data warehouse, they would have designed the data model using the star schema technique or snowflake technique. Now let us understand what is star schema. So you can see that in the middle, this single table got linked with many tables. All the surrounding tables are talking to this guy. That means, it got linked with this one, right? All the tables got linked with this table. So this is your sales table. Okay, and this is your territory table, and this is your reseller table. This is your product table, and this is your customer table. So these are called your dimension tables. Dimension tables. So in the case of star schema or snowflake schema, you will have two types of tables. One is the fact table, and then the set of dimension tables. See, what are the set of dimension tables? It depends on your record. In this case, you want to do the slicing and dicing of your sales table by customer dimension table. You need to do the customer table. See, supposing you want to see overall your potential customer, top 10 customer, which customer spends more in your website. Okay, obviously you need to have the customer information. And again, the product information, which top 10 products sell by sales or profit. Obviously, you need to have a table called product. Customer table, product table, and says it. So yes, one person he asked, why should I have so many tables? Can't I keep all the information in a single table? it's a mess, right? We don't keep it. See, even in our house, we don't keep all the food in a single container, isn't it? Right? The same thing here. So, and also in the interest of saving space and performance point of view, this kind of, you need to store the data in different tables. There are different relevant tables. Okay, customer information is in a customer table, product dimension you can store product, all the product labels you can store in a separate table. And territory, all the regions is stored in a separate table. Stockist, resales are nothing but stockist, you can store them in a separate table. Okay, and sales order is another table. This is kind of one-to-many, one-to-one relationship here. Okay, each order you will have a single record here, but this single order you will have multiple. Customers would have purchased more than one item, right? So with the line key they can differentiate it. Okay, fine. So this is in this case you have fact table and set of dimension table. In the case of star schema, the fact table is surrounded by multiple dimension tables. Hence, it is called star schema. Why it is called star schema? As a fact table is surrounded by multiple dimension table. Okay, don't ask me this question. So, in a star schema, can I have only one fact table? You can have more than one fact table also. But in general, you will have minimum, right? At least one or two fact tables. You will have it. Not many fact tables, because the fact table will hold huge volume of the data, transaction data. Every day, every minute, whatever the orders raised by the customer, that one will get stored here. This is our sales fact table. This is a shipment, fact table. Okay, you receive the orders and then you generate the invoice and each orders when it got shipped. That detail to capture that they have another fact table. So sales fact table, and then a shipment fact table or fulfillment fact table, you have it. And here, for example, at one point you wanted to see which all customers, or give me the shipment status by customer. You need to have this dimension table. Even this dimension table needs to be linked with this one. Okay, and which products we sold in which, or shipped in which shipment, right? So for that also you need to have these tables. So you have two fact tables and multiple dimension tables. The end of the day, the fact tables are surrounded by multiple dimension tables. The fact table in general, you will have oddly one or two tables will be there. There are some cases 3 will be there. One is like a transaction. Even the shipment is also kind of a transaction. Daily shipment, whatever happens, that detail they store it there. And apart from this, there's something aggregated fact table. So these are your transactional fact table. Apart from this, you have some kind of aggregational fact table. But the idea here is, in the case of star schema data modeling design, your fact table will be surrounded by dimension tables. Okay. In the case of fact table, what information we will have it? What information we will have it? In the fact table, you have the facts plus keys from dimension tables. Dimension tables. The dimension tables will have the surrogate key, which is nothing but the primary key, surrogate key, plus the descriptive information about the facts. Okay, what do you mean by the fact table consists of facts and keys from dimension table? What do you mean by facts? Facts are nothing but measures. Sales amount is one of the example for facts. It's a numeric value. Facts are nothing but numeric value. You just think that way. You will have the combination numeric value as well as the keys from dimension. Suppose you look here, you have customer dimension key, customer key from customer dimension table, product key, and you have territory key. Here you have date key and or line key and reseller key. All these keys from your dimension, surrounding dimension will be kept here. Look here, the customer key, here it is there, and here also you have it. Product key, everything. So all the dimension tables key column, you will have it. Along with that, you will have the facts. For example, if I tell you something like 102, let's 1102.32 or 210. This is my fact, sales amount. If I tell you sales amount, only this number, does it make sense? If I tell you simply, hey, I have a number 21,102.32. So what is the next question that you will ask? Okay, this is fine. This is sales amount. You are saying that, but sales amount for what? For a specific product. Let's a customer bought a washing machine. For that washing machine, this is the money they paid. Which customer paid? That customer name, right? So to give context to this value, you need to do a lookup in various dimension table to get the customer name, product name, everything. The customer name, product name, everything will available in this table. Whereas here only the key column will be there. When you join this table with this table, it will do a lookup for example, WM, that's the product key. It will go and look up the product key here, WM, and what is the name for the product? The product name will be here. To get the product name, the fact table has to join with your dimension table using the common key, product key and product key. Okay. So that is how, the relationships are created here. So the fact table consists of the dimension key columns from all the surrounding tables plus the facts, the sales amount. The facts are nothing but the sales amount or gross sales, net sales, and net margin, something like that. Okay, you have, and also you have the units sold, right? Units, how many units we sold. These are the numeric values, facts. These are called your facts. The fact table consists of the combination of the keys from dimension tables plus facts, and then the dimension table will contain the primary key column. The primary key column is called as a surrogate key here. The customer key, product key, these are called your surrogate key. And each customer, there will be only one record will be there. There is no duplicate here. Okay. Hence, to make sure that there are no duplicate name for the single customer, we use a customer key column, which is nothing but your surrogate key, okay, and plus descriptive information. In the sense, what is this model is all about, okay? For example, our customer, right? With the customer, and what is his first name, what is his last name, and what is the address and contact number or email ID, everything, it will be there here, okay? So to provide the context to the facts in your fact table, you need to have the dimension tables. With the help of the dimension table, you can provide context to this value. For example, who purchased, who spent this much money? If somebody is asking you, then the customer key from this table will be joined with the customer key in this table. Because in this table, when the customer name is there, to get the customer name, these two tables, you need to join it based on the common key column customer key, and then only you can get the customer name. So to provide context to this number, the descriptive information for this fact is stored in your dimension table. So dimension table consists surrogate key plus the descriptive information about the fact table. And fact table consists of the keys from dimension tables plus facts. That's it. Keep all numeric values in fact tables. Keep all descriptive information and surrogate key into other tables called your dimension tables. And then fact table are surrounded by dimension tables. And the dimension table joined to the fact tables. Okay, here's something. The dimension table are not joined to each other. Yeah, you need to remember this step. All the dimension table will get joined with your fact table, but there is no relationship exists between these two tables. The dimension tables are not linked, or you don't create the relationship between the dimension table. All the dimension table will get linked with your fact table. Yeah, the dimension table is to join join to the so the dimension tables are used to get the context information about your fact table. Now you understood what is star schema. A star schema is nothing but fact table is surrounded by dimension table. And in the star schema or snowflake schema, you will have the fact table and then the dimension table. The fact table will contains the key columns from all the dimension tables plus facts in it. Whereas the dimension table will have the surrogate key and the descriptive information about your fact. That's all. Next one is the snowflake schema. If you look at the snowflake schema, it is an extension of your star schema. Here also we have the dimension tables and fact table. The fact table is surrounded by the dimension tables. But if you look at here, these dimension tables were not directly linked to your fact table. This dimension table got linked here, and then this dimension table got linked here, this time. But if you see, this dimension table is not directly linked to my fact table. Similarly, these two dimension tables were not linked directly to this table. So in this case, the dimension tables, what they do is the single dimension table, they will split it into more than one dimension table in the interest of reducing the storage. So here they add additional dimensions, usually which represents hierarchies. For example, country is the top of the hierarchy, isn't it? Each country you have multiple location, the country and then location and then dealer. Each country you have multiple location, and each location you have more than one dealer, right? So they create the dimension tables to represent the hierarchies. But if you wanted to filter the fact table using the dealer dimension table, that is possible because there is a direct relation exists between these tables. But if you wanted to use your location dimension table to filter the fact table, you cannot do the filtering directly. The fact table has to filter the fact table via the dealer table. So in this case, you need to join these two tables to filter your fact table. So if you want your location table to filter the fact table, it is not possible. It has to navigate through the dealer table and then only it can filter it. It is something like you cannot talk to your your company because only your friend has a close relationship with the company. Okay, you have to talk to your friend in order to get the information from the company. You just think that way. Maybe this analogy is not the correct one. You just think that way. Okay, in that case, you have to depend on your friend every time to talk to the company. In the sense, you need to join multiple tables. Joining tables, especially huge volume of tables, that will literally slow down your performance. Hence, even Microsoft, they recommend better you can use star schema. The best practice for data model design is what they suggest is use star schema wherever it is possible. In case of any rare situation, you can go, if the customer is already having snowflake schema, nothing can be done. We can suggest them why you need to have multiple tables, combine these three tables in a single table, so that the number of tables will get reduced. You can suggest them. If they say, no, we don't want to combine these three tables because the volume of the data are very huge. If I combine it, we will end up having so many redundant values in my data set that can leads to more disk storage requirement. Okay, it requires more disk storage. More the disk storage, obviously, that can also add overhead in terms of slowing down your performance. But on the other hand, when you join multiple tables, that is also painful. If you join multiple tables, wherein if those tables have huge volume of data in it, it will literally slow down your performance. So on a case-to-case basis, you decide whether you can use star schema or snowflake schema. But we are not the deciding authority. The management has to decide. Okay, but if they ask you to give some recommendation, you can suggest them better use star schema. But again, on a case-to-case basis, you need to suggest them. Okay. So they will ask you in the entry, what is the difference between star schema and snowflake schema? In the case of star schema, the fact table is surrounded by multiple dimension tables, whereas in the case of snowflake schema, the dimension tables are, there are dimension tables that are not directly linked to my fact table. sometimes the dimension tables itself got splitted into more than one table, and in those dimension table will have the relationship between the parent dimension tables also. Okay, in case of navigating, or if you want to filter table A, you want to use your table A to filter your fact table, you have to join the table A with table B, and then table B has to fetch the data. Okay, that is the difference between Snowflake and Star Schema. The fact table we already discussed, and these are the types of fact tables: are the transactional fact table and the periodic snapshot fact table, accumulating snapshot, and factless fact table. This is called your bridge table. What is factless fact table? See, if somebody says fact table, in that fact should be there. What do you mean by fact? The numeric value, the measure should be there. There are cases measures will not be there, only the key columns will be. That is called your the factless fact table. They'll ask you all these questions. You can tell them as the name suggests. In the case of factless fact table, the fact we don't store it. We store only the keys. Then, okay, you store only the keys. For what purpose? So we want to use a factless fact table as a bridge table. This can lead to another question. So what do you mean by bridge table? Why you need a bridge table? In the case of any many-to-many relationship exists between the table, we need to use a bridge table to do the filtering. In that kind of situation, I need to use the factless fact table. Okay, what is transactional fact table? Whatever the sales, they do it on a daily basis, all the transaction will get loaded into my fact table also. And periodic snapshot, there are some cases we don't have to load the data from your source system to your fact table on a daily basis. Every once in 15 days or every once in a week, you wanted to load the data into that fact table. That is called your periodic snapshot. Accumulating snapshot is something like every week, what they do is they will keep aggregate the values and then store it in a fact table. They do the aggregation, the aggregated fact table. So in that case, if you look at the data in the aggregated fact table, you can see what the total sales we made in week 1, week 2, week 3, week 4. Okay, and second week, third week, second month, third month, 12 month, each month, week 1, week 2, how much sales we made. Before storing the data, does the aggregation, sum or average, it computes it and then it stores it there. Okay, that is what your accumulating snapshot table. Okay, and then this is what your factless fact table. You have something called salesperson table, and then you have something else called region table. There exists a many relationship between these two tables. Supposing you want to use your salesperson table to filter region table, you cannot do it directly. Why? Here, if you see here, a single salesperson, the single salesperson might have worked across different territory or different region. And each region will have more than one salesperson. Hence, there is a many-to-many relation. In that kind of situation, you need to have a factless fact table to filter, these two tables. That we will discuss it a little later, don't worry. At this moment, we will continue and understand the different types of relationship. The relationship is also called as a cardinality. Please remember that in the intro, they'll ask you, what is cardinality? If they ask you, you can ask them back with this question. Hey, what do you mean by cardinality? Are you asking about the cardinality from the data modeling point of view or from the categorical column point of view? Okay, in that case, if they say data modeling point of view, then they are asking about the relationship. So what is cardinality? Cardinality is nothing but relationship. So what are the types of relationship is there? So why we need a relationship? Filtering. We have seen it, right? When I delete the relationship, it is not doing the filtering. Cardinality is nothing but relationship. It is, relationship is nothing but filtering in Power BI, right? So relationship between what are the different cardinality types or relationship types are there? Types of relationships are there? One-to-one relationship, one-to-many relationship, many-to-many one relationship, many-to-many relationship. What is one-to-one? Can someone give me an example for one-to-one relationship? A citizen, say citizen in India should have only one Aadhaar number. And also a single Aadhaar number has to be assigned to only one citizen. You have something like two tables, citizen and other number. Here, each citizen is a kind of a one-to-one relationship here. Okay, each citizen should have only one Aadhaar number, and each Aadhaar number should be assigned to only one citizen. It should not be assigned to the same number, should not be assigned to more than one person. In this case, this is a classic example one-to-one. If you are in USA, you know, right? Social security number. Here we say Aadhaar number, they say social security number. Okay, give me an example for one-to-many relationship. One-to-many relationship. So in this case, a single employee, for example, employee is working on multiple projects. A single employee is working on more than one projects, P1, P2, P3. Another example is a car manufacturer. A single car manufacturer produces multiple, more than one models, right? More than one models produced by car manufacturer. And these are the example for that one. And then many to one relationship. Many to one is opposite. In a single project, many employees are working. Sorry, many to one, right? Here, what is the example for many to one? So this is many side, right? In this case, multiple project or multiple employees, right? Here, listen, multiple employees are working on single project. Multiple employees are working on single project. Here, one employee is working on more than one project. And here, in this case, multiple employees are working in a single project. That is an example, many to one. And many to many relationship, we have discussed a while back. And let's go and see the other examples for the employee. A single employee is working in more than one project. A single car man produces many car. A customer can order more than one item. A single customer can order more than one item. Yes, you are correct, Priyanka. And the next one is the many to one. Multiple employees, more than one employee can work in a single project. That is what, right? If you take any project, multiple employee, more than one employee is working there. More items ordered in a single order. These are the examples for many to one relationship. Many to many, the example which I gave it here, right? This is the one. A single salesperson is working across multiple regions, and each region will have multiple salesperson, more than one salesperson. That is an example for a many-to-many relationship. Anyhow, we'll discuss about many-to-many relationship a little later. First of all, let us understand how to create relationship or data model design in Power Pivot. Power Pivot is nothing but our model view. So this is what our model view. Look here, in this case, in the interest of time, I'll show you. I have loaded all these tables. And then I have, created the relationship. In some cases, what happened, it created the relationship automatically here between the tables. It creates the relationship between the tables automatically. Okay, as soon as you load the data, and if you come and see it here, especially when you have multiple tables, if there are any relationship, any common columns exist between the tables, it automatically creates a relationship here. For that, I will open another report file and I'll show you a new report file. It automatically creates the relationship between the tables. Get data. I just click on it here and I'll just click on Excel workbook. Sales fact tables. I just load a fact table. This is my fact table. I'm going to select I want to use the first sheet. This one is not relevant to my thing. I selected, I looked at it. I'm going to hit load. Okay, if I go to the model, here also I can see the table, loaded table. This is my table, and there are some columns are not helpful. Okay, we can remove the columns as part of data preparation we can do, but in this case, I'm not going to do anything. So the fact table is ready. And I call that as a fact table. Okay, I'm going to load another table called dim customer.xls. Hit open. And here I'm going to select the sheet one here. Yes, I'm going to click on transform data because the column names are not showing correctly. It requires some kind of promotion. We need to promote the row to a column. I just go over here and then here. This first row as it is. Yes. I'm done with it. I'm going to click on file, close and apply. I'm going to rename it to dim customer so that it will be easily understood. And NC sales, I just say that sales fact table. Look here, when I go back here, look here, it creates the relationship automatically between the tables, isn't it? Customer and how it created this line link. And if I scroll up, yeah, and if I hover the cursor on top of this line, you can see that in both the table, cust ID column got highlighted. Since these two tables have the same column name, cust ID, it automatically creates the relationship. But while creating the relationship, it checks whether the customer IDs are repeating here more than once. If it is not, it is one side. And if the same customer repeats multiple times, that means a many side, one-to-many relationship. It creates the relationship, okay, automatically. Okay, the next one is get data, and I'm going to select another table, dim product dimension table. I'm going to hit open. And this is the one I'm going to select. Okay. But there is not much difference between Excel file and database table. In most of the cases, you will be connecting to the database tables only. Okay. But if the table size are small, then you use import. If the bigger table size are there, right? Bigger tables are there. You need to use the direct connect. Look here, the relationship got created automatically, right? Beautiful. How it is possible? Because in both the tables, a common column is there, product ID and product ID. Now the question is, here the product ID instead of product ID, product code is there here, whereas here product ID is there. In that case, it will not create the relationship. It will not be able to understand how Power BI can understand the product code is same as product ID, right? It doesn't have that much of intelligence. Since the column names are same between the tables, it thinks that, hey, okay, there is a relationship, it creates a relationship automatically. Supposing in your data set, right? In the product dimension, they've given product key, and here you have something called product ID, then it will not create the relationship automatically. In that case, you need to find out, you need to manually review the data model design after you load the files, and then go and check any tables are not linked with the other table. That means there is some problem. Okay, for example, your product key is your product ID. Is there, very well this product key is nothing but product ID. Then you can just drag and drop it on top of this column. The link will get created. So only in that kind of situation, you need to manually create the relationship between the tables. Otherwise, it automatically detect the relationship, and it creates the relationship between the tables automatically, which one? The Power BI. But what they recommend, even though it creates automatically, you need to revisit it and make sure that it creates the relationship between the tables based on the correct columns. Okay, fine. So once you have created the relationship, the next one is you have another table. Likewise, you can load all the other tables. It will create the relationship between the tables automatically, but you know very well how to create the relationship manually. Sometimes, let us say you don't see any relationship in the report. Sometimes what will happen is, let's say you're a project developer in your project, right? You would have left the company. The very first day when they give the report to you, you go and see it if there is no relationship. Again, you need to see how product and in product, these two are common, and you can create the relationship between these two. Try to drag and drop it here. Okay, and then make sure that you hover the cursor on top of this link, so that both the tables, the common column names will get highlighted. It should get highlighted. Okay, it will highlight customer ID, but make sure that the customer ID column here is not linked with product ID or any other. Customer ID should link with customer ID only. In this dimension table, whatever the key column, the surrogate keys, product ID. This product ID should get linked with product ID. This product ID don't mistakenly link with discount. Sometimes due to oversight, you might drag and drop the product ID and drop it on top of some wrong column mistakenly. So to make sure that you have done the create the relation correctly, you need to hover the cursor on top of it. Hover in the sense, keep the cursor on top of this link. Product ID, product. Yes, correct. The relationship got created. Correct. This is how you need to create the relationship, or this is how you need to validate the relationships created was correct or not. Sometimes, yes, you need to click on the manage relationship, and this is what you are. This is another way of creating the relationship between the tables. For example, I don't have the relationship exists between these two tables. Let's assume that way. Okay. The one way of doing is product ID in product ID. You can drag this and drop it on top of this one, or else you can, the other approach is click on the manage relationship icon and click on new here. And here you select, click on the drop down here, product dimension. And then here you have the sales fact table. What columns are common here? Look here, product ID and product ID. These two columns are available in these two tables. It automatically got selected. Okay, look here, if you select, it will get selected. It got selected automatically. And then there is a section called cardinality, one to many. If you click on the drop down here, you can see that one to one, one to many, many to many, many to one relationships are there. It automatically detects the relationship, right? The cardinality also between this one to many relationship. And cross filter direction, you have two options. The intro, they'll ask you what are the options are available in cross filter direction. You need to say single and both. Okay. So this is the default one is single, okay, and the cross filter direction, and it's a one to many relationship. And here, the common columns got selected automatically here, and hit OK button now, and then close it now, and wait for some time. A link will get to look here. It got created automatically. This is another way of creating relationship between the tables. And if you see here, all the key columns or the ID columns, right? It is flowing from your dimension table down to your fact table. Fine. So, right. This is how you need to create the data model design, and we will load some other tables. We have something called date fact table, everything. What I will do is, I'm getting calls from office. Even today, we have some release activities are going.